Hello my dear lovely students, welcome back to my channel. Today we are going to explore something very interesting and fun, palindromes and some amazing number patterns, which is in class 6 chapter 3 number play. Let's start. What pattern do you see in these numbers? 66, 848, 575, 797, 1111. Do you notice something special about them? Yes, these numbers read the same from left to right and from right to left. Such numbers are called palindromes or palindromic numbers. Isn't that cool? Once you just try and see. What is the definition of palindromic numbers? Palindromic numbers are those that read the same from left to right and from right to left. Next, all palindromes using 1, 2, 3. The numbers 121, 313, 222 are some examples of palindromes using the digits 1, 2, 3. Write all possible 3-digit palindromes using these digits 111, 121, 131, 212, 222, 233, 313, 323, 333. Now we are going to try a very interesting activity called reverse and add palindrome. Here is how it works. Start with any 2-digit number, reverse its digits, add the number and its reverse. If you get a palindrome, stop. If not, repeat the steps. Let's try some example. 34 plus 43 equals to 77. 77 is a palindrome. 29 plus 92 equals to 121 is a palindrome. 48 plus 84 equals to 132, which is not a palindrome. So we repeat 132 plus 231 equals to 363. Now we got a palindrome. Some numbers reach a palindrome quickly. Some numbers take many steps. 76 plus 67 equals to 143. 143 plus 341 equals to 484. This is a palindrome. Try the same procedure for some other numbers and perform the same steps. Stop if you get a palindrome. There are numbers for which you have to repeat this a large number of times. Are there numbers for which you never reach a palindrome? For this question, the answer is no. Already we have seen that how to get a palindrome. First take any 2-digit number, you reverse it and then add it. 34 plus 43 equals to 77, that is a palindromic. Next 27 plus 92 equals to 121. Next explore. Will reversing and adding numbers repeatedly starting with a 2-digit number always gives a palindrome? Try this procedure for different numbers. You may need to repeat the steps many times or sometimes only once. This activity helps us to understand patterns and relationship between the numbers. Here I am taking 12. 12 plus 21 equals to 33. It is a palindrome. 56 plus 65 equals to 121. This is also a palindromic. Now let's solve a fun number riddle. The riddle says I am a 5-digit number. I am an odd number. My T digit is double my U digit. My H digit is double my T digit. Who am I? Let's think about it. The number has 5 digits. The last digit must be odd. So what are the odd numbers? 1, 3, 5, 7, 9. Then the tens digit is double the ones digit and the hundreds digit is double the tens digit. So if you see 1 double 2, 3 double 6, next 5 double 10, 7 double 14 and last 9 double 18. 5, 7, 9 we will not get because the double number is 2 digits are there. Only consider 1 and 3. Next 1 double is 2, 3 double is 6, 6 double is 12. So 12 is a 2-digit number. This also will not come. So in the unit place we will write 1, tens place we will get 2 and 100 place we will get 4 and next 1000 place we have to write 2. Next 10,000 place we have to write 1. So the number is 12,421. Next they ask to write the number in words. So the answer is 12,421. So in this video today we learned about palindromes. We made our own palindromic numbers. tried the reverse and add activity, and even solved a number puzzle. I hope you understand about palindromic numbers. If you have any doubts regarding this video, please ask me in the comment section. Thank you for watching. If you like this video, please don't forget to like, share and subscribe for more videos. See you in the next video.